Hi everyone, this is another test on the small version of the mostly magnet motor, and this is the 1-inch cube magnet motor version. And I wanted to do another test to compare it actually to a DC motor here. And the test that I had before was using a speaker and most likely that speaker is not very efficient as the pull force of a motor of this kind. This DC motor is a 20 volt motor, and it actually is a very low RPM motor. I believe this is about like a 400 RPM motor. It was used on very large video, 1-inch video tape machines as the rewind motor. And so it has a lot of torque but low RPM. And I think that would be a better motor to compare, because most likely if I would change this into a motor action, it would require a crankshaft, and we'd have about 400 RPM, I believe, once this is operating in the 10 hertz range, which I think is probably its average. Probably it might go up to about 15 hertz. That would be probably its most you'd want to drive that at. So most likely this would actually have a RPM of 400 to 600 RPM, in that range. So I found a motor here that would be a good comparison to this. So the results are a little different, and I'll go through the tests here. So this is still my regular 40 ohm coil here and 250 millihenries, and I don't know what the DC resistance on that was. Be very low. It's probably around 1 ohm or somewhere around that range, and the inductance, I don't have a reading either. Doesn't matter. I think it's not all that important at this time. So I'll turn on my scale here, and I have my voltage and current there, and I have a switch here to activate it, and we can see now we're at 0 grams. And when I activate this switch here, then it kicks in. So it is now activated, and we can see we have 515 grams of pulling force. So this test is for the 500 gram range, and we're at 4.2 volts at 102 milliamps. So that is the motor there operating. I'll switch the switch off, and now what I'll do is I'll connect the power to this DC motor here, and it's rigged up with this scale right here, and it's to a shaft here that I put on the end of this rotor here, and basically the alignment here is exactly the edge around the outside edge of the rotor inside there. So the rest of that dimension of the motor is basically the magnets and the case. So it's basically a 1-to-1 ratio, just like this one here is a 1-to-1 ratio, and we're going to give that a try. I'll just have to pause the camera. Okay, the DC motor is now connected, and all I need to do is flip the switch, and there we have 510 grams pull for 1.33 volts at 606 milliamps, or 607 milliamps, around that range. And there's our pull. Shut that off, and let's do the math. Okay, so there you go. There's the math, and this is the mostly magnet motor. We had 4.21 volts DC at 0.103 amps. It gives us 0.433 watts input for 500 grams pull. And this is our DC motor. And we had 1.33 volts DC input at 0.607 amps, so that is 0.807 watts. So we're much closer. So obviously using a smaller DC motor of higher RPM is not a good comparison, because like I'm saying, this mostly magnet motor would never reach thousands of RPMs. I think it would operate more in the range of about 400 to 600 RPM. So quite sure we have to compare it to motors that would have the same RPM range. And this motor here may be an ideal candidate for that kind of thing. And as you see, we're closer, but we still, the mostly magnet motor still beats it close to twice. And what you have to also take in consideration here is the footprint. This is very small compared to this very large DC motor here. But I wanted to use a very large DC motor to see the efficiency difference, and there you have it. So that is the difference between the two. So the next step would be to finish my build of the super version, and that one there will obviously blow this away, and I'm quite sure more than 10 fulls. So and I would say for the size and all that, it would be a comparison or a fair comparison for what that would be compared to this one here. This one here, we have to keep in mind, we have very thin wire for the coil. We've got 40 ohms DC resistance in there. That is wasting some power there, and the super version will only have somewhere around 2 ohms in the coils. So that will be much more an efficient design, I do believe. So stay tuned for the next updates. Thanks. Bye now.